Good day and welcome to this lightning talk. Today I would like to present results on a new hybrid X-ray radio method for measuring the cavity powers of active galactic nuclei. In particular, we're interested in studying the amount of radio mode feedback in galaxy clusters. The situation here is that we have a supermassive black hole located at the center of the cluster. This black hole emits two radio jets in opposite directions. These expand into the ICM against the external pressure to form radio lobes. Based on this interaction between the radio lobes and the ICM, we can measure how much energy is actually being injected by the black hole into the cluster environment. These measurements have generally been performed mostly based on X-ray observations. Of course, in the X-ray, you don't observe the radio lobes directly, but you do observe the ICM. And where the radio lobes are, you generally observe cavities instead. People have also tried to use radio observations for these measurements, for instance, based on luminosities or spectral properties, but generally X-ray observations have been the preferred way to do this. Key ingredients here are the cavity volume, the amount of ICM pressure that is acting on the radio lobe, and the distance from the core. We propose a new hybrid method based on a combination of observations. So we use the X-ray observations to use the ICM pressure that is acting on the radio lobe, and we use radio observations, in particular LOFAR, to measure the cavity volume and distance to the core. LOFAR is really an ideal tool for this because it's, of course, a low-frequency array, meaning that it's quite sensitive to the quite complete radio lobe, even the older plasma. And of course, if you have on baseline observations, that's really an ideal combination of sensitivity and resolution. We hope that this method will allow us to go further in redshift, where the X-ray observations generally struggle a bit more with clearly detecting the cavities. And we hope that then the radio can synergize with the X-ray to go deeper into the universe than we have currently. So to show you how this method actually performs, we have studied a sample of 14 targets with both the international baselines and the Dutch array, where we use both methods, both the X-ray method and the new hybrid method, to measure the amount of feedback. First of all, of course, we look here on the left where we see the measurements of the cavity volume that we observe in the X-ray and the radio, and we see that they lie very closely on the one-to-one correlation line, the dashed line here, indicating that with the radio, we are indeed quite sensitive to the quite complete cavity volume. And if you then propagate through the numbers to actually calculate the corresponding power that is associated with this, we go to the plot here on the right, where we again see a quite good correlation between these two quantities, indicating that the two methods actually do produce consistent results. We go into more detail on the exact strengths and weaknesses of the new method in the upcoming paper. So keep an eye on arXiv. Thank you very much.